In this problem, we are given two types of pattern. One pattern is character based, so it will be like A, B, A, C or something like this. Another pattern will be of the same size, but it will have some word. So let's say word 1 space word 2 space word 1 space word 3. So first of all, if it has different number of characters than the number of words here, then straight away you can say that it's invalid. So what you have to do is that you have to match this with this. So one word should correspond to one character. So if one character is occurring 3 times, that same word should occur 3 times at exact same positions. So if number of characters is different from number of words, that is invalid. Or even if they are same, then you have to match that A corresponds to word 1. First one, ordering is important, and words are separated by one single space. And all the letters are smaller, lowercase English alphabets from small a to small g. So word 1 corresponds to A, word 2 corresponds to B, next is A, but A has already occurred. So here it must be word 1. If there is any other word, then it's invalid. So in this case, it's valid since word 1 is here, word 1 is here, first and third place. Then it's a new character which has not occurred before. So it's a new word which has not occurred before. So this is what we have to do here. So let's take one concrete example. So we have this pattern A, B, B, A. So clearly first and last are same. Here also first and last are same, dog, dog. Second and third are same. Here also they are same. So it's a valid pattern. Now here this is the same pattern, but here you see that first, although second and third are same, first and last are not same. So this is invalid pattern. So how can we solve it? So whenever we are iterating through this pattern and this word list, we will keep 1:1 correspondence. That is, we start iterating from here, that is I equal to 0, some counter. So we pick ith character from here, that will be A, and we pick ith word from here. So in C++ we will use a string stream to extract the tokens from this sentence. In Java and Python we will use the split function that is available to us. So first word is dog. So we need to keep a map so that whenever we detect a character, we check whether it has occurred or not before. If it has occurred, we will check its dictionary that what was the corresponding word. So it was dog. In this case, it will not be there the first time we visit it. And if the character has not occurred first time, then we check whether this word has occurred or not. So if this has not occurred, then this also must not occur. So both we have to check. So both have not occurred in this case. So we insert A as the key and dog as the word, and there will be another dictionary where dog will be the key and A will be its value. So both ways. This is, let's say, called char map. This is word map. So both were absent, so we inserted in both of them and we move ahead. So now we come to second one. B is not here. We check whether cat is here or not. Cat is also not here, so it's good. Both are new. So we insert B cat and cat B. And then next character is B. So we check whether B is present or not. We see yes, B is present. So we fetch the corresponding word. It's cat. We match with this word. It matches, but that is not enough. Maybe B cat is there, but cat has something else, C also, or something else. So this is not enough. We will check here also. So cat is present, and what is the corresponding character? It's B. So we see that B matches with this. So both should match each other. So it's valid. Next we come here. We get A here. A is present. Then we check whether dog is present in this or not. If it's not present, it's an error scenario. Because A was present, then dog must be present in this other map. So if it's present, then we fetch the value. It's equal to dog, that is this word. And then from this we fetch the character corresponding to dog, and it's A. So it matches. Now similarly, if we look at this example, so here A is not present. So we insert A dog and dog A. Then B B cat, cat B, then B, it matches. Then finally we come here, I is here, so we get A. So we check A is present or not. A is present, so we get its corresponding value, it's dog. And we check what is the current word. So I is both 1 to 1. So when I is here, it's fourth character, and here it's fourth word. So we see if this matches the current word or not. It does not match, so we return false. So this is how we will proceed. So what should be the time complexity here? We have two maps. So map 1 contains n characters and n strings. Similarly this one, so 2 times that. So again, depending on the average word length, let's say average word length is W, then NW is the space complexity, and also time complexity can also be O of NW, since hashing function can internally, if let's say all the words are new, then it needs to create the hash of this word. So that hash function would depend on the number of characters, although we don't have a specification for that. So for now you can think of time as O of n, assuming that everything is constant time in hash. But if the words are distinct, then of course the hashing function may be of the order of width, but let's ignore it for now. So time is order n, space is order nw, or you can think of it as order n. So both are linear. So let's write the code for this. First one is char to string, and the next one is string to char. So this string stream is used to extract or insert. So this is general string stream, not I or O string stream. You can also use I string stream, since here we will be just getting value from this. And then we will have an index. Index is starting from 0. So here we don't have all the words beforehand, so we cannot straight away check n equal to that words dot length, but in Python and Java that will be available. Here we will be extracting one at a time. So there we will keep checking that if we have more words but we have reached n, then it's invalid scenario. So that way we will check. So this means we got a new word separated by a space. So if I is equal to n, that is we have more characters, that is we have more words than number of characters. So character is n, so max index should have been n minus 1, but we have still more words in this S string stream, so it's invalid. Then if char, what's it's called, char map dot count pattern I. So let's save it beforehand. Char c equal to pattern I, since we will need it multiple times. Count c. So if it's present, it will be 1. If it's not present, it will be 0, because duplicates are not allowed. So count will be either 0 or 1. So if it's not equal to word map dot count word, so each word is read in this word variable, and so this is the t. So if these are not equal, that is char is present, word is not present, or vice versa, then return false. Now if chars dot count c, So this line ensures that if they are unequal, that is only one of them is present, return false. So this line we don't return from here. It means that either it's not present, both are not present, or both are present. So now we will check if chars dot or char map dot count c is equal to 1, then that means it's present. So what we will check, if so it's present means it's present in both. Word map word not equal to c, or char map c not equal to word. In both cases it's false. Else, this else means neither char not word is present in their corresponding maps, so we will insert it here. So char map dot insert, first one will be the character will be key in this one, and the value will be word, and then word map dot insert, and also don't forget to increment the I, because we are using I here for making comparisons, and also finally we will return I equal to n. And the solution is accepted. And we are here 4 milliseconds. So you can try a few times. I'm pretty sure you will get 100% accuracy. And here you get 0 millisecond, that is better than 100% of the submissions. Now we will write this in Java and Python. And here we don't need this. So we can straight away get the words array using split function, separated by single space. So if number of characters in the pattern is not different from number of words in this string, then return false. If char map contains the key C, so this will return boolean true or false. This is not same as word map dot contains key word, then return false, exactly same as what we did in C++. And then if char map dot contains key C, then if word map dot get word not equal to C, or char map dot get C not equal to word, or rather we cannot compare this using this. We need to use dot equals not equals, then return false, else we have to insert it. So this else means it was not present in both of them. So chars dot put C word. So char map and word map dot put word C. And Java solution is also accepted. Finally, we will do it in Python. So if C in char map not equal to word in word map, and the Python solution is also accepted.